All right, welcome everybody. Thank you very much for joining the IIoT World Manufacturing and Supply Chain Days. You are joining us for Data Factory and putting your data to work. That is important. That is, top of mind with many, many companies, especially with manufacturing. Before we get into all of the great information that'll be presented by Hitachi Vantara, they are the sponsor of this particular event. I want to make sure that you use the Q&A tool to be able to ask your questions. We want you to ask questions throughout the presentation. We will make sure that your answer or your question gets presented to these two fine individuals, and making sure that you get the information you need to be successful, which is top of line for everybody. Before we get into that, remember, again, use that Q&A tool to be able to ask your questions, and we will make sure that they get that information. All right, before we get cracking, we've got two wonderful professionals that know exactly what's going on. Rich Nagel and Stephen Garbret. Did I get that right, Stephen?
You did. That's excellent. Yeah.
All right. Hey, thank you very much. All right, man. And before we get cracking with the presentation, give us just a brief background on you, Stephen, as well as you, Rich, starting with Stephen first.
Okay. Yeah, so glad to have everybody attending the session today. My name is Steve Garbrecht. I've been working in operations software and IoT solutions for about 30 years total, different integrations. So I've seen kind of the progression of data management as it applies to OT, and then more recently how it applies to IoT and then even enterprise data management. So I have the function of product marketing for the Industrial DataOps and IoT products we have at Hitachi Vantara.
Yeah, hi everyone. My name is Rich Nagel.
All right, Rich. Tough act to follow. Bring the energy, baby.
My name is Rich Nagel. I'm a solutions architect working with our Lumada DataOps suite of products. I'm out of the Los Angeles area. I've got a background in engineering with a wireless background, and I've been in pre-sales for about the last 12 years, mostly with IoT deals, but the last year and a half or so also with IT and data management. So it's nice to meet you all. Look forward to spending some time with you.
All right. And once again, thank you very much for joining this particular session. And again, reiterate, Q&A, make sure you post, interactive, pepper these two professionals with your questions, and you will get the most out of this session. Take it away, Stephen.
Great. Thanks again. Really appreciate it, Scott. So, this session, we're going to talk about the data factory and what does that really mean from an operations data management point of view. And stay tuned, because we're going to talk a little bit about the capabilities and use some slides for that. But then we're going to show you actual products that you can use to do this function here that we're talking about of industrial data management. Now, the focus, and we talked about putting together a primer for operations professionals. So, as I said, I've worked a long time in operations areas with, dealing with operators and supervisors and plant managers in what they've been using for data management and the idea of SCADA and visualization and things like that. And really, it's all about operations performance. But what we're seeing is there's a massive attraction between the IT technology professionals and the operations people to pull off this digital transformation type of an effort that needs to happen as part of that. And we want to help to bridge that gap from an understanding point of view and talk about this in kind of the context of how your operations work today. And once again, help you experience some new IT focused tools that help to really enable this for your organization. So first of all, let's talk a little bit about why industrial data management is so important. Why do we even care about this, right? We just want the operations to work, right? We want them to be optimized and have the processes work the way they want to, right? But if you look at manufacturing, these are the 5 pillars of things that we focus on as operations people to improve the business, right? There's the idea of safety, quality, energy and optimization, uptime and asset utilization, and also regulatory requirements. These are the things we worry about and we work on from a supervisory point of view to make sure that things are working properly. Now, every one of these things has a data component to it. And it needs a basically a data matters for each one of these things. So let me give you some examples as part of this. So first, starting off with plant retrofits. Let's say we're going to optimize and expand our manufacturing operation. We're going to put in a new line, maybe a new building, a new process unit, for example. There's a lot of data that goes into the planning of that and the orchestration of what should be done. Engineering design drawings, maybe there's video footage we've captured of how things are working today, where can we make improvements in things, operations reports. All of that information needs to be highly accurate. So it needs to be curated and basically validated that it's in the right state to be used in decision-making processes. And these decisions are very important because we can do things very well, we could do them poorly, which would reflect on the safety of the overall operation and what we actually build as an extension to a line. Maybe recalls are also important, right? So in a manufacturing organization, everybody knows that when a recall happens and we've discovered a quality problem that went out there into the customer base, it's all hands on deck to understand what happened, right? All this data comes together from LIMS systems, online sensors of different things that how things were made, and capturing the actual performance of what the different products were that were there. Certificates of analysis, locations of material, not just within the factory, but also up and down the supply chain, where they came from, where is that quality problem initiating from as part of that. So data lineage and understanding data across multiple sources becomes very important to be able to improve your quality. Next thing around plant optimization. So optimization, we've done a lot of optimization over the years in energy management and unit level type optimizers. But now we're looking at broader contexts, right? The HVAC systems, the weather, the different aspects of the materials going into the plant and the energy associated with moving those things, right? Being able to correlate that data and normalize it and understand it in context is important to be able to pull that off. Then you have the new capabilities of predictive analytics that are coming in. So being able to create machine learning applications, which requires you to create data sets that are very accurate, and also to be able to make sure that the real-time data that's feeding those analytics in runtime, that they're producing the right data for information for people to use as part of that. So accurate machine learning information is highly important, which affects my uptime. And then all important regulations. There's nothing like a new regulation or a new requirement coming from the government. Circular economy type things are coming in, emissions requirements. So there's lots of different data that you're storing as part of that. And by the way, you should never throw data away, right? Data is the new currency. So why would you ever throw it away from an organizational point of view? You can use it for different purposes. So being able to provide the integrity and the trust and the self-service of this data for reports and being able to manage your regulatory requirements is part of that, to avoid the fines and the other problems you may see in the marketplace as part of that.
Stephen, I have a question for you, and that is around data quality, right?
Mm-hmm.
When you say you're going to sort of hold on to that data, the data is gold and all of that, sometimes that data is just poor, it's been pencil whipped, right?
Yep.
How do you address that? Because that's all part of that.
There's several aspects to quality. One is the belief that you need to clean your data as close to the source as you possibly can. Right, so it's coming off of the equipment, for example. Detecting whether the data is within range, if it makes sense, and having rules in place that automatically sensing if the data quality is part of that. The other thing about data quality, quite frankly, is understanding the data. 90% of all operations data is not understood once you leave the operations group. Right. So think about salespeople and the marketing department, the planning department, the supply chain people. Understanding that data is also a quality problem, right? So how do you document it and tag it and apply more metadata to it to make it more understood?
Yeah, I think that's key. And clearly, Rohit Sharma had this question before. So I'm going to pop a question to you, Stephen, real quick. Does customization of IIoT solutions for each equipment like motors and pumps result in a higher accuracy and more capital efficient solutions?
Yeah, I think, well, the more data, the better for machine learning. That's a given, right?
Yeah.
And also being able to augment the data that's already there. So we've done some work with digital twins where we input data from physics-based simulators, for example, to create synthetic data. That'd be data that doesn't exist in real life, like an acceleration number or something like that really needs to be calculated. And also, comparing that theoretical operation of the equipment to what's actually happening. Right. So yes, all that data enrichment can help things from a machine learning point of view.
All right, Rohit. I hope that answered your question. You keep popping in. We've got other questions, but proceed forward there, Stephen.
Great. So what are you missing as if you don't have this professional data management capability that we're talking about, right? First of all, it's very possible you're missing your project goals as part of this. If your goal is to implement digital transformation and start with a project at an individual site from an IoT point of view and roll it across multiple plants across the enterprise, having that standardization ability helps you, really prevents you from doing that, right? Maybe you're not achieving your KPIs through that standardization. So once again, if I can take the best practices of how things are operating at an individual plant and make all of my plants come up to that level, all boats in the harbor rise to a level if one goes up, then that makes a lot more sense. Operating losses. So building new optimization analytics. It's not just about developing one analytic to do, prediction of failure of equipment. You want to come up with different analytics quickly to be able to optimize your operation and customize those for the way your company works, so you get a competitive advantage as part of that. And then we're all dealing with employee problems right now. People are leaving the industry. We're trying to get these new younger people to be excited about working in industrial operations and manufacturing. If the analytic alerts that we're creating and the things we're doing to help to give them prescription and prediction of what to do aren't giving accurate results that they would expect, they're not going to use them, right? So we really need to take into account the data that's feeding those analytics in order to do that. And there's real financial implications as part of all this. Now, the concept of professional data management.
We've got a question. Oh,
go ahead. Yep.
I'm sorry about that, Steve. Go ahead. Sachin has a question that I think you could probably answer, and it is a good one. When and how does one decide if the data is required? Good point. Will be required or not required? So, is that data okay, or do we need to even go down that road? How do you make those decisions?
Yeah. So there's, and we'll talk about that in the tools that we have too.
There you go.
There's a concept of metadata and the actual data, right? So, one of the things you have to first start off with is make sure you've cataloged your data sources properly, so it's understood, what it is and is an accurate representation of what the data is, right? And that can be done through the cataloging process and understanding, how you're tagging things. Then there's the actual data as it's coming across. So, there's different techniques to sense, as I said, what is going on with the data. Is it falling in parameters of what you would expect to see? Is it, in some cases for data sets and data feeds starting off, as a subject matter expert looked at it and said, yes, this makes sense. This stream of data or this data set that may be historical is accurate. And I'm therefore going to, apply my stamp of approval to it as part of it. So there's different ways of sensing, the quality of the data and also curating it with, with people to understand that it is the right quality and should be used for a certain purpose.
Excellent. I hope that answered your question. Thank you, Sachin, for your question. Continue.
Great question. Yep. And let's talk a little bit about a data ops. And data ops is really the professional way of managing operations data and both IT and OT data for the purpose of analytic applications. And we call those data products many times inside of a company, right? So you hear the IT organization talk about a data product, and that's really, something that delivers value for somebody to do their job more effectively as part of that. And the different steps associated with that, there's the ingest phase, which includes accessing, collecting data and then blending it. Then there's organizing and structuring and grooming and curating that data, which applies governance and also understanding from a data catalog point of view. And then there's the assembly process for the analytics, where you're actually creating something that's consumable by somebody and publishing it. It could be a report. It could be a data set that now people can use. It also could be an analytic application, a Python-based application, for example, that's doing prediction or prescription of something for somebody, right? And to have a standardized process in place for doing this. And the key thing to note is that 70% of the work to do any of this is in the data prep. So being able to prep this information, this data, and turning it into information that can be used in analytics is very important. So this brings us to the concept of the data factory. So today we know a factory ingests different materials, raw material parts, could be basic raw materials. It helps to organize and structure it, assemble it inside of a production line, for example. It will groom and polish and curate those parts, make them more complete. It adds value every step of the way along the production process, and then actually packaging it and labeling it for use within a customer, right? Same concept with data management and data ops. Different types of data coming from control systems, from historians, from MES systems, those events activities, the structured data. With unstructured data, new data sources like video and pictures and LiDAR and things like that, and supply chain data. And then also semi-structured, so it could be documents or alerts, events, simulations, design documents and things like that. Putting that all together to create analytics that describe what's going on in real time. So I have an alert and a notification of something, predict what's going to happen so I can take action ahead of time, and then prescribe to somebody what to do. What knobs to turn, what things to do to optimize something, to take advantage of a process opportunity or a profitability opportunity, or reduce emissions and help to drive more value inside of the organization.
A question. There just seems to be, or potential for, a data tsunami. And me as just a simple guy, it would be hard for me to first say, yep, there's data. I know you're telling me I need to know about data, and I need to be able to grab that data because there's gold in that data. And then all of a sudden I've got to figure out, can I select a low-hanging fruit? Can I have that evaluation of saying, okay, we get all this data, but let's just look at this one right now. Let's get some wins over here. Is that a decent approach?
Yeah. You don't have to, eat the whole enchilada at once, right? You can take bites at a time at it. The data that you needs to feed the objectives that you may have. So let's say that you're trying to work on your quality improvements. So therefore, you would try to pull in LIMS data, ERP information. Maybe you're putting in some inline sensors in certain areas to sense quality, and maybe you're also trying to pull in information from your suppliers, right, and interface that data. So trying to assemble that information for the purpose of a general area of quality improvement you would focus on, right? So you don't have to say, okay, I'm gonna spend millions of dollars and not get any value out of it right away. You can take and just approach the things you're going to get value right away from it. And the key is having a platform in place that lets you add those things as you need them.
And you're agnostic in the sense, this particular, I love the word picture that comes with data factory. I like it. But you're agnostic in a sense that we've got these legacy systems, and it's like, hey, this is great, and you're able to connect because I want data from over here as well as data over there, and I see the importance of that data. So when you start looking at the data factory, can you just sort of pull all those legacy systems together?
Exactly. A lot of us as manufacturers have grown through acquisition, right? And there may be multiple ERP systems you have as part of that acquisition. And then you have these systems in place that have intellectual property built into them, the SCADA systems, the historians, the CMMS packages. You don't want to replace that stuff. It's doing its job, right? You want to add to what's going on as part of that. There's still a lot of AS400s out there that are running MES applications, for example, right? People aren't even there to even touch that code or do anything there. So yeah, you want to basically build on what you already have. And that's where an integration technology is really important, where you can set up these data streams and then have data pipelines that are handling the transformations to convert it into the way you need to be, check the quality as it comes along, and kind of integrate those things together with a broader context or a broader initiative that you have of improving something in the business. Right?
Yeah, I like that. Yep,
Yeah.
I like it.
Yeah.
All right.
So with that,
Continue.
let me turn it over to my colleague, Rich, and we'll show you a little bit of some standardized tools that can do this and make it really easy to accomplish.
All right, thanks, Steve. Can you hear me okay?
Yes. Yeah.
And let me share my
5
screen.
by 5.
Can you see my screen okay?
It's coming in. And again, just before the information pops up, remember to just enter your questions into the Q&A, and we just pop it out for there and then get their input. So keep that, make sure that you interact with this presentation. Continue.
All right. So I really like this data factory analogy to how we manage data. Anytime I go on a manufacturing floor, you always learn about the complexities, the different processes, the different trade-offs that are required, as well as really the technology that helps. And so much akin to taking raw materials in and producing a product that's useful, our data engineers and analysts and scientists do the same thing with grabbing that raw data from different sources, and then doing the cleansing of it, the transforming of it, and publishing it so it can be consumed into an analytic that'll be useful for someone to make decisions downstream. And so what I'm going to share with you are the technologies that we have to be able to implement these data transformations and structuring and publishing. And so what I have is I've got two tools. One's called Pentaho, and Pentaho is a data integration tool. It does business analytics as well. And so I'm going to use that in our first step here for data ingest. I also have a data catalog, which is very useful for automatic discovery and tagging of your data and empowering the business with to be able to trust in the data that they have. And so for this first step here with data ingest, much like a factory, the data engineers will have to grab data from various different places. It might be IT data, it might be OT data, and they'll have to put it through pipelines to be able to get that end result. I need to get this data in a certain format or transform it in a certain way so that it's useful downstream and turn it into an analytic. And so that's the first demonstration that we're going to do. And to do that, I'm going to use a tool called Pentaho, which you can see here. And so this is a transformation that you're looking at. It's a medium complex transformation. And what we're looking at here is a tool called Spoon, which is the tool that we use to be able to create these transformations. And they consist of different steps to be able to transform the data as it goes through this pipeline to finally give the data out. And the other tool I have here is an MQTT client. And so I've got some OT data that's coming in. So I can execute this. And if you're familiar with MQTT, it's going to publish this JSON data, a long string of data that's coming in from my machines on the floor. And I want to be able to use this data to process it and to come up with analytics. And the analytics I want is really just to look at the end result. I want to be able to have a dashboard that has data coming in to be able to look at my processes. And so I just started that, and I see some data coming in for my energy consumption, my health. But one of the analytics that I want is called OEE. And if you're familiar with manufacturing, it's operational equipment efficiencies. And so basically that's a product of availability. Is the machine up and running as it should be? Its performance, is it performing as fast as it could? And the quality, is it producing good product or not? And so what I don't have is this availability, because for the machine that I have, this coffee roaster, it's not really giving me any data that tells me, hey, it's available for doing what it should be doing for production. So I've got a bunch of data coming in, and I need to infer that. And that's what my data pipeline is going to do. And so let's look back at this data pipeline here. And before I get into this, let's just talk a little bit about Pentaho, a data integration tool that very easy to use and intuitive. It creates jobs and transformations. What we're going to do is create a transformation, and that will do the pipelining process. And we also have jobs, which will do the orchestration of several transformations and handle errors and do restarts and things like that. But for the transformation, we want to be able to connect IT and OT data. And so we can get data from various different places. One might be an Excel or a CSV file. And this is really easy to use. I just drag and drop this on and I can browse for a file and bring that in and say how it's delimited with a column. And then I'm able to preview that data, which I'll show you in the demonstration as we go through it, and pass that data on. Many times you might have existing databases where data might reside. And so I can grab that data from a database too. And I'll be able to, in this case, I've got an H2 database that's here. But if I wanted to, I could select any type of database that I wanted to that has a JDBC connector. You'll see a lot of different types that are here, and then connect to that data. And then the tool will help you with the queries to be able to select the data that you want and bring that in. And so great ways of bringing in IT data. And what we'll talk about too is different ways of bringing in some OT data. And that's often done with MQTT. And so I've got an MQTT consumer that's here. And so I can bring that data in as well, which I'll show you in the transformation. And then finally, you want to be able to transform and output that data. So you might have something like a calculator where you can take data from all these different steps here. And it's just it's a matter of just connecting these together to be able to do the transformation and join this data to be able to do a calculation on the different information that's coming in. So that's the basics of how it works. And so for our demonstration, what we're looking at is a simple transformation. Well, it's a set of medium transformation that will take the data in from an MQTT feed. And so I've got a step here that's an MQTT consumer. And so what I'm doing here is I'm connecting to where this MQTT broker is, and I'm subscribing to this topic, which is what this data is being produced on. And I'm putting in an output to a sub-transformation that's here, which is called Coffee IT OT OEE. And so this is gathering the data. And every time I get a line of data in, I'm going to pass it through this. And it's going to create a field that's going to be able to send that JSON that's coming in here into this data. And so this is just simply getting the record from the streams, and the stream is just a message. It's just that long string of JSON data that's coming in. And so what
this is the ingest step, right? This is just ingest.
This is the ingest step, yeah.
Got it.
And so what I want to do is I want to calculate that availability. Okay. And so for my coffee roaster, like I said, there's nothing there that says, hey, I'm available. And so I use my domain knowledge, my operations engineers on the line that know that, hey, when that cooling drum is running, when that spindle is above 50 RPMs per minute, I know that that machine is actually engaged in a process that counts towards availability. And so we want to count that time that drum is running towards our availability time. And availability is simply just the operating time when that drum is that cooling drum is running versus the planned production time, the overall time that I allocated for that machine to run. And it can be affected by downtime. It can be affected by supply chain starvation. And so if it was 100%, I want my operating time to be match that planned production time. But often it's less than that for the said reasons. And so that's what I'm going to do. I'm going to be able to take that spindle RPM that's coming in all this data here and take that and see if it's greater than 50 RPMs. And then I'm going to calculate my availability metric. And so once I get that data in, I'll parse this JSON, and there's a step that does that. I take that message and I can get the fields that I want. From all these fields, really the ones that I want is that spindle RPM that's there and a timestamp of information. And maybe I want to do the quality metric and the performance metric as well too, so I can grab those too. So I take that and I pass that along, and I'm also grabbing some data from the IT side. What is that planned production time? So I can grab that data from a database and like I showed you before in the other widget and bring that in. And so I can perform that calculation. And then what I'm going to do is join that data together and then do a calculation. And so in this step, this is a JavaScript step where I've got a simple calculation here where I've got my spindle RPM that's coming in. Is it greater than 50? I'm going to add 5 seconds to my runtime. And so I've got two aggregate times that are going, my planned production time and that actual time. And I'm going to pass that out. And so now I've got this aggregated runtime based on that spindle. If it's running, I count that towards availability, and I do a simple calculation after that. And so this is the calculator step where I can do a bunch of different types of calculations here. based on what I want to do. And so I'm going to create that availability metric that I have. And it's going to be based on that roster runtime, that aggregated operating time that we have, and the elapsed time for the production time that we have. And that's going to give me my availability. And so that's great. I've got my metric, but I'm much like manufacturing, I'm not done yet, right? I need to package this up and send it off where it needs to go. And so in this case, it's going off to another MQTT topic that's going to be stored in a database once it gets there. And so what I need to do is create a JSON output. So I'm going to create these fields and put that off into an output. And then I'm going to have an MQTT producer that's going to send this off. I could send this off to a Kafka stream. I could send this off at various different places, but I'm going to go back and send this on a topic that's called coffee data clean. And so this is where the transform data is going to go out, and then it's going to show up on my website. And so if I go to this transformation here and make sure we start the data, okay. And so I've got my data that's coming in, and then I'm going to execute my my transformation with this step, and I'll hit go. And now every single time I get data that's coming in, I will have that transformation occur. And I can subscribe to that consumer set, that coffee data clean. And then I can see the data that's coming in from my my operation. And if I go back to my metric here, looks like we had a slow start for whatever reason. It was down to start, but you can see this building up. There's my availability information and my OEE calculation as we have it. And so, you know, what do we learn? You know, much like a manufacturing plant where you can take data in from various different sources and transform it, that's exactly what the Pentaho tool does. It takes in your IT data, your OT data, and can perform all different types of complex processes to be able to mold that data into the analytic that you want. So that's the first example of what we have for ingest.
Hey, Rich, let me interrupt real quick. So
Yeah.
for clarification, what's the name of the system? You said Pentaho or?
Pentaho, yeah, Pentaho. And
Okay, gotcha.
Yeah, it's been around for a while, and it's quite comprehensive to be able to work with ERP systems as well as, you know, data
good
things like that. Yeah.
Can I pepper you with some questions right now?
Yeah, please.
And please, for the people participating in this, just let's recognize that I'll do the best I can pronouncing the names, but if I mispronounce them, it's not meant to be anything negative. But anyway, with that said, Ramaha, I'm going to go with that. Which is better place to optimize data collection? At edge device level or at the cloud level? Rich?
Yeah, I think it depends. I mean, it makes sense at the edge for a lot of places, a lot of times, because you know, you've got low latency capabilities there. You can minimize bandwidth there, and in the distributed compute, you don't have to load up the core. You can have all that distributed compute power at the edge, and so there's a lot of reasons why you would probably want to do it there first. But that's not always the case, but generally most of the time that would
even the flexibility of your platform, the solution, you could pretty much pull it pretty much everywhere.
Yeah, that's right. That's
okay.
Right.
Yeah, good deal. Thank you for the question.
Sure.
Proceed forward.
Scott, you are breaking up right now. So.
Oh, I'm sorry. I wasn't saying it. How about now? Do you have them?
Yes.
Yeah, that's better.
Go ahead, Rich.
Okay. All right. So step two, the organization and structuring of the data. And so, you know, we've got a great little picture of bins here with storage where, you know, your parts can be stored there. But this needs to be understood throughout, you know, your line workers, what's where, and the quality of it needs to be good so that they can operate well. The same way that we have this need on the manufacturing floor, we've got the need for data too across the organization. There's various different silos, and we need to be able to have a way to do a discovery of that data and to trust that data to make sure that we can use it for analytics. And so that's what our data catalog does. And so I'm going to give you a quick overview of the data catalog product that we have. And let me re-log in to this. And so, as I said, if you're not familiar with a data catalog, really what it's used for is for automated discovery. So you'll have various different types of data that's across your organization, not just your manufacturing data, but all different types of sales data and whatnot. You need to be able to assess the quality and the lineage of that data to be able to trust that data. You're not sure where that data came from as a data analyst, or maybe someone that needs to understand this. And so a tool that's able to give you that is extremely useful and needed. And then, finally, it empowers the business with just the standardization of vocabulary, the business glossary that's there to be able to understand OEE and availability. If I'm a data analyst that has to, understand this and as well as maybe marketing data or whatever it is, it's difficult to be able to make sure that the data that you have is in the terms that you know. And that's exactly what this tool does. And so how does it do this? So, with all this information that's here, how does this information get into here, and how do we tag the data and make sure it's trusted and discoverable for our end users? Well, first you have to get the data in there. And so what our tool does, we've got our coffee roasting data. So I've collected some data, that OEE data that we created. I'm putting in a file system that I can access. And so my data, I have agents that will go and discover the data across my organization. And so what they'll do is I'll tell the agent where that data is at. And I create a data source, really a virtual folder. The data isn't stored here, it's stored wherever it is, but the agent will know it's there, and it'll take a profile of that to be able to understand it better. And so how that's done is really I have a data source, and I've got several here, and I can create one. In this case, I created that coffee roasting data source, and it's really easy to do. You really just give it a path to where that data is at on the machine where it's at. And then a bucket. In this case, it's in an object store where it's at. So it's able to grab all that data, all the files that are in that data, that database, and be able to bring that in here. And then, that's great. I've got my data that's there, but I want to be able to profile this. And so there's processes that I can tell the agent to run. These jobs can be kicked off however you choose to do so. But I'll do a data profiling. And what this will do, our agent will go out and will look at all the files, inspect them, inspect all the data that's inside of those files, and figure out, is it a string? Is it a number? Look at the consistency of it. Look at how big is it? Is it a social security number? Is it an address? And then take a guess of what, based on your vocabulary that you have of tags and your vernacular for your organization, of what that might be, and I'll put a tag to that. And so that's what I've done already, and that's what's happening here. So if I go to my coffee roasting, I can see my contained items here, and I've got several different files that are here. And so the end result of that is it's able to tell me what information's inside of here. And so I've got these different tags. I've got my OEE and my availability. And, a lot of times this is why you need a data catalog. 8% might be used in this data here, but really what I want is the ability to tag that and say that, hey, this is the availability, this is the metric that I want. And in this case, I've got a data scientist that's going to be useful for the next step that we go to, that needs to understand this production data that we have with the output, along with the energy information that it's used, because they want to do a calculation, not just for what we wanted to see how efficient our process is, but also compare that across different lines to understand energy consumption versus the efficiency of productivity. So that's why these things are important. So I've got my data that's here. And it's got the different tags that are on it. I can see a lot of information about the data, where the lineage is there, the different statistics. I know that, okay, this is a relative humidity, and it spins in a range between 40 and 59. Okay, that helps me to build trust with this. And then also I've got my tags. And so if I look at the tags here, it can have one or more tag, and you'll see that this is relative humidity. That could be affecting my coffee bean production process. And if I view this in the glossary, I can see this tag here, and I can assign different rules to it. And so the different rules that I have can be, if I inspect this data, it can have a certain, is it complete? Is it valid? Is it consistent? And then I can also use this to automate the discovery of like data. And so much like in a manufacturing line, if you have something that's tedious and repetitive, and you want to be able to automate that process. And so what do? You use automation and machine learning, and exactly what this tool does as well. And so I have a tag, and what I did was I can either have a regular expression or a value that I have. And once I confirm that value is truly the tag that I have, I can use that to teach the tool to be able, in the next iteration, to be able to tag that automatically. And that's how it works. That's the secret sauce with this data catalog, to be able to tag it. And after a few times, the machine will know and have an understanding of, hey, this is my best guess. Can you confirm this? And then be able to tag that data appropriately. And so in here, I've got a seeded field with this relative humidity. This RH is going to be tagged automatically with the data that I have from my data there, because that's what I confirmed. If I look at maybe another example, if I go into my claims information, I can see some claims data, and I might have something like this, a member ID, where I have a key field here with well, basically I pulled the wrong one, but you would have a dotted line around here with actually what I wanted to show you was weather information. So let me go there into our bookmarks. Here's some weather data, and I've got some wind speed here. And so if I look at the data elements where this is suggested, I can see that this is a one that is suggested. And if I pull this up, I can see that this has an 83% chance of being wind speed data. And by looking at this, I can go and actually tag this as an accept or reject. And once I accept this, then the machine learning algorithm will learn and be able to automate the tagging of all this data. And so what's the end result of this? The end result is just being able to find the information that you want, make it easy for those data analysts. Instead of calling around and asking if data might exist or might not, they're able to do so by just doing a simple search. And so if I have a data analyst that wants to find some coffee production data, I can see some fields here that are availability, or I can see the resources that are here. And then I can see curated data that's been certified, and find that data, and then combine that data for, since I know to trust this with my other data sources, to be able to do production versus energy consumption analysis that I have, all made capable by a data catalog. And so that was a second step. Hopefully, the usefulness of that, to be able to understand your data, label your data, and trust your data is useful for your analysts. And I'll finally go to publish.
I'm going to ask a question there. Neil has a question.
Please, yeah.
And I think it's going to be reached out to you. I've taken my video off. I want to make sure that the sound quality is decent. Neil asks, do you also take advantage of feature engineering to train your ML model? ? If yes, are there specific tools or platforms to do that, or it's done through 100% coding? Is that to you, Rich, or Stephen?
Yeah, Steve can help with that. I mean, what we use is its proprietary algorithm that we have to be able to inspect the data and profile that data and come up with a signature of that data. And so it will know if it's 5 digits or 10 digits or whatever it is. If it's 10 digits, it might be a phone number, for example. And then it'll look at the data next to it and really take in everything that data has to create a signature to be able to have a fingerprint for that data. And that's really how it works behind the scenes.
There you go, Neil. All right, continue, Rich.
Yeah. And our final step here is publish and consume. So we grab that data from different sources, we pipeline it to transform it into something that's useful. We've tagged it so our data analysts can understand it and trust it. And now we want to be able to display it for our management that needs to get insights here and make decisions about the business. And so for this, we're using Pentaho again in the business intelligence aspects of Pentaho. So for this, I've got another transformation for you. And so what we're going to do here is we're going to look at another way that Pentaho can be used I've got, my data coming across different plants here. Maybe it might be an Excel file where it's an older plant. They just still have a lot of Excel spreadsheets for production. It could be in a database as well, and then MQTT input. And I can bring that data in, and I want to be able to enrich this data by tagging it. I'm going to tag it with a location and a name, and it's going to be in California, and that's going to be line 1, and I'll have line 2 and 3 here. I might want to do some enumeration on the data. Maybe I've got a timestamp that isn't readable, and I can make it into readable months, days, and hours. The key part here is to annotate measures and dimensions. And so what Pentaho can do as part of the packaging process is to help with the data model, to help create a very efficient way that you can inspect this data. And so I'm going to create measures, which are the measures that I'm interested in, the kilowatt waters and hours and the output, as well as the other data that's there. And I'm also going to create dimensions. And so in a pivot table type of format, I can create location dimensions and time dimensions. And so I can see these paired against each other. And then what I'm going to do, I'm simply just going to load this all up into a database. And then I'll have that data that I can create a model off of. So if I run this, this will execute. And then I can go to my Pentaho tool for a business analytics and be able to bring that data in. So and analyze it. And so here is the PUC, the Pentaho User Console. And this is where you can view your transformations and create different types of analytics. And so if I want to browse my files here, I've saved that transformation. It might have logged out on me.
Well, let's, oh, are you back, log back in?
Yeah, let me do this.
So here's a question that you get. Here's a question. This is Michael Grant. How do you know which data stream is relevant for a specific process or use case? Question mark. Conversely, how do you ensure you don't ignore data streams that are not obviously important, but end of mattering in unforeseen ways? Does that make sense?
Yeah, well, first question is how to understand what data is important.
Yeah.
Is that right? Yeah, that's good.
It's just like, yeah, data stream. I would say that, Michael, pop in if you're saying that's something else, but I agree with you, Hannah. Yeah, Rich, go.
Yeah, I mean, obviously that's a challenge. I mean, you think of the first example where, you had data that wasn't really telling you what availability was. How do you know that? And that's where a lot of domain knowledge comes in. The human factor in understanding data is there. And that's where we use our data catalog to have trusted curators to be able to, or domain experts to be able to tag that data appropriately. And with a combination of that, you build the trust and understanding of what that data truly is and can share that across the organization. So I don't know if that answers your question, but that's the brief answer I have.
There you go. Okay, you back up. Well, that's not a good sign, right? That little pouty face
isn't a good sign. But what I'm going to do is, for whatever reason that was down, I'm going to go over here. And just show you some examples of the Pentaho tool. I wanted to show you that specific use case because I can create a pivot table with that data where I can look at the output versus power, but really the types of data that we have here or analytic reports are like this. And so you have pivot table type of capabilities where I can, in this case, it's a sales data, and I was going to have line information here versus California. You can see your output versus your power consumption. And then in many cases, look at the data in different ways. Maybe I want to be able to, well, of course, I can export this to a PDF and then share this with the organization, but also just have different ways of, maybe it's pie charts to be able to look at this data or bar diagrams that will show me how much, who is maximizing output versus the consumption. That would lead me to more insights. And so this is one report that we have. Another one is the vendor sales report, and which is an interactive report that we have. Also the interactive dashboards that we have for sales information as well. This is just a dashboard, but I've got a number of different widgets that I've created. It could be an interactive report or whatnot. And then I can click on the data that's here and be able to see data relevant in different areas. And so really the tool allows you to not only view all this data in a way that you need, but create those different types of reports. Create that data source. We've got a widget that I was going to show you that really just reads the information from that table and creates those dimensions so that you're able to look at the data and analyze it in this way. And you can also do some administration things as far as kicking off different jobs and automate the process for scheduling these processes and whatnot. And so that's the end part of it. You know, once we've got the data together and entrusted it, we put it into these analytic solutions, and then we're able to share that data or consume it visually as needed across the organization. And with that, that's what I had for stage 3 of our demonstration. Any questions about this?
We do have some questions, which is I'm going to try to pepper, and I'm going to hopefully do okay with the question. This is a fun show. In a world, and this is just reading it, in a world of supply chain tech transitions, how well do we trust data integrity with the previous tech generation holding to normal norms of operational procedures?
Oh, that was a mouthful.
It was, it's, I tried, but parse it out.
For data integrity and how do we trust it? You know, hopefully it's becoming obvious. Obviously, you have to, and that's where the data catalog helps. Once you ingest that data, to have it into a data warehouse or a trusted source, a source of truth, right? And from there, with the lineage of the data catalog, you're able to see that data came from a source of trust. And so the integrity of that is created from you know, the sources and the curators that manage that data, builds the trust across the organization for that. With the new technology that's coming in, and really it would go through the same processes of wherever that data comes in from, to go through that scrutiny of you know, making sure that it's trusted and building that lineage out, and the quality of that data so it can be used, or understanding the quality of that data so it can be used downstream.
You know, just I love the analogy of the data factory. I can see it. It's you know, sometimes data can just be sort of nebulous. It's data, right? Whatever it looks like, but you're allowed to be able to put that in that data factory. Another question that has Neil came to the table again. At the final stage, would the system help develop a QR code or label with all aggregated info to enable efficient tracking and tracing?
Yeah, it can. With Pentaho, you can have pixel perfect reports. And that's one thing that I didn't get to show, but the, you know, in one of these examples that are here for our samples, you can see that you've got barcodes on this one. And so that can be printed out in really any way that you want the forms to be printed out. There's a report designer that allows you to do that. And you can send variables to it so that it can adapt as needed when it creates those reports specific to whatever the product or specific item might be.
There you go. And I have Sandra Mueller, and I hope I said that right. What is one of the most remarkable use cases you have encountered thus far? That's sort of the human side.
Remarkable use cases in data.
Which is interesting.
You know,
you probably never heard that in a sentence before, right?
No, one that's always impressed me is just the clever ways that technology is used. You know, with energy consumption's one, and if you understand electromagnetism, to understand energy demand across state lines, some companies have put inductive sensors to be able to gauge the change in electricity. So for financial markets, they're able to make decisions more readily. And so that's, you know, where you've got some really good know-how about how to get sensor information and extract that, and then use tools like this to be able to grab that data in management and send it through a pipeline so it can be analyzed and used to be able to make money in that case. That's one example that I think is pretty clever.
But you got to admit, it's an interesting time, and the ability to be able to gather the data and your platform, your tool, help facilitate, and to a certain extent, an easy way of being able to gather it and put it into a tangible way. I think it's an exciting time. I've got my old hat on, and it used to be a bit of a challenge to collect the data that is important. All right, we're running out of time. A couple of things. We do have, just continue to ask the questions. We'll be able to get back to you with answers. So if you have any additional questions, I'm sure that both Rich and Stephen would be able to answer it and get back to you. Go ahead, Stephen, with the last slide.
Yeah. So Scott, thanks again, Rich, and for that great demonstration. So, what we showed you today was some simple tools and we showed you how you could use them out of the box, right? You notice there was no programming. It was all drag and drop. It was all, configuration of aspects. We even had a visualization environment that you could use for building the reports and the dashboards and things. Others like to do programming. So these tools are totally set up. So if you want to use Power BI with it, you can use it. If you want to create a data feed that goes into an S3 database in AWS, and you want to use their tools, you can do that. You want to integrate together any kind of an IT data source. It could be ERP, it could be supply chain information, it could be CRM information, it could be coming from an external party. You can do that. It's very flexible in how it's used, and depending on your level of capability, you can do lots of things with it, right? So really the call to action, which, this session was geared more for people who come from the operations space, right? And what you're used to. You see that there's some IT tools and IoT tools that can be provided here to really help out with data management even more effectively. So talk with the people that are responsible for data management in your organization. It could be the on-site people for plant IT, could be the control engineers, it could be the IT people in the operations groups that you're working with that are building analytics. So the data science team. Reach out to them and reach out to us also. We can help with these conversations. We've had lots of conversations with IT and OT people in the same room, helping to understand how they can work more effectively together, how the modern tools can be applied and solutions can be applied to get to the right data management that you need for things. And I want to let you know too that the tools that we showed here, you can evaluate these things and use them without any commitment at all. Here's a couple of QR codes. If you scan those, and we're going to provide the PDF versions of this too. You could also scan it on your recording right here. It will give you to a link which will let you download Pentaho or a data catalog to try it out yourself. We have 30,000 people a month that download Pentaho as an enterprise tool, and it's across not just industrial organizations. It could be banking, insurance, medical, and they use that for data integration and data transformation. And same thing with the catalog too. We have a lot of people that download that. And please visit our website to understand more about Lumada Industrial DataOps in the portfolio. We have use case examples there. We have success stories. We have more information on how we can also integrate in IoT, and we have a full IoT platform capability, a core platform capability that can be used for analytics and help to build those analytics and train the models as part of it. So we're here to help. So please reach out to us as part of that.
All right. Thank you for your participation. Thank you all. Thank you, Rich and Stephen, and of course, Hitachi Vantara for sponsoring this event. Remember, take them up on that opportunity to get more information. Well worth it. And thank you for your participation in the IIoT World Manufacturing and Supply Chain Days. Enjoy the rest of the program.